All right, friends. So we have a three-phase motor here that had gotten over-greased and the bearings had worn out. We are looking to replace it so that we could fix this one, have it as a spare. The function of this motor is to turn a centrifugal pump that runs chill water throughout our building to help keep it cool. The scope of this video is going to be to replace this motor and go through the shaft aligning procedure in order to, make that happen. First step of this procedure is obvious. You got to power this fucker down. The next step is just a sanity check. Make sure that this thing is no longer in rotation. Next step of this task is to remove this rotor shroud so that we can better access the entire pump motor assembly. Now that our cover is removed, we can assess the current state of this union and how it is put together. It is important to mark the position of things. We're trying to do a one-to-one swap here, so the more information you can leave yourself for reassembly, the better. So we're marking where or exactly how this union is married onto these collets on these two shafts. And now, we're taking this apart. And now that the union has been removed from the collets, what we need to do now is disconnect the motor from the electrical wiring feeding it. So, important part of this process is to mark your wires so you know which hot wires are attached to which leads inside the motor. So once you have that going, you just loosen everything up, pull it all out, and you're on your way. And at this point in the process, we need to make some crucial measurements to make sure that the new motor we put in place tracks in the same exact position as the old one. So right now, we're measuring the distance between the threaded holes of the collets. And now we are putting on this shaft alignment tool, which is a neat thing. This is the first time I've really done this. And the idea is that one side of the tool, or the tool fits on the pump side of this shaft. It's what's fixed. And what we're going to do here is we are going to put on a couple calibrated dials along these rods that will touch the collet of the electric motor's shaft. And it's really just marking its position in a three-dimensional space. So we got one that's measuring in the, I'd say, X direction, and then another that's measuring in a little bit more of the YZ direction. And that was actually just because of the constraint of the space that we had on hand. Either way, what we're measuring is the parallelism and the concentricity of this. So we zero out these dial indicators and we rotate this tool around the electric motor shaft, and it is giving us a real-time visual display of how true that these shafts are to each other. So now that we have all of our measurements taken, we're able to pull this motor from its base by removing the 4 9/16 bolts that fit at the feet of the motor. We then brought the motor over here to our new motor and did three things. One being we moved the collet from the old motor to the new motor, setting it at the same distance away from the end of the rotor as it was on the previous motor. Second thing is we adjusted the wiring configuration inside the motor to reflect that of the old motor, being the 480 volt configuration instead of the 208 volt three-phase. Third thing is we flipped that electrical box upside down so that the hole was at the top for our conduit to feed through into. As a test, we are going to just wire up this motor before we do anything, just to make sure it runs. So we fire it up and we give ourselves the sanity check and go and take a look, and yes, we see that it is running. Praise the heavens. So this came the first attempt where I tried aligning this motor with our shaft alignment tool. And I had the naivety to believe that, oh yeah, this is the same motor. It should be a pretty easy one-to-one swap. I couldn't be more mistaken. And I honestly should have known better about that. Because yeah, as I mount this motor onto the base, I realized like, these tips are not touching. This is way out of alignment. I'm gonna have to do a lot of work here, and oh shit, I don't have any shims on hand either. So I had to make an emergency order of shims because I couldn't seem to find any in town. And yeah, had to really just postpone the project until the proper equipment came in. So in the meantime, I realized that one of my big problems was the feet on this thing were flanged. So I couldn't quite get a flush fit on those bases anyway. And every time I would try to torque down those bolts, it would pull on those flanged feet and just get the whole thing out of, just cockeyed and completely out of alignment. So I had to unwire everything and pull it off, and yeah, I'm just pounding these feet flat right now just to try to make more of a flush fit on this base. Now that I got flat feet, I can take this thing back and put it back on its motor mount and thread it in there ever so gently and go ahead and begin with the process now that I have these shims in my possession. So it's tricky. We gotta just put these bolts in, bolt it down, and you go back and forth and you're just playing and playing and playing with these shims and just trying to see, okay, maybe like this shim under this foot will cockeye this rotor in such a position that it just gets it into that angular and parallel alignment with the opposing pump shaft. And this took me about 2 hours of playing around with it, but I got it where I wanted it to be. My goal was to just be within 10 thou, and I achieved that, if not even better. It seems to be actually oscillating around that zero inflection point pretty much similarly as the old motor did. So I'm pretty thrilled about that. And one final check that we have to do for this is make sure that the motor is snug. There's a thing called soft foot where these shims can actually be loose. So we need to physically wiggle these shims, make sure they are tight underneath the motor, which we have found that they are. So that is a point of relief. So we're secure on all 4 feet and we're ready to put this thing back together. So now we're just going through the process of rewiring this. We have our leads taped and numbered, so it's a pretty one-to-one sort of process. We just need to thread the wire in, attach the ground, wire nut these wires together, and button the whole thing up. And yeah, at this point, we just replace or remove the shaft alignment tool. So we're just very much on the home stretch with this. I was very reluctant to remove this just because this was such a process, but hey, that's what commitment looks like. So as part of putting this thing back together, we need to make sure that the keyways are 180 degrees out from each other so that they balance each other out rotationally. And I found that this union can only really fit on here one way. So the markings weren't so important, but it was good for me to look out for myself in that regard. So we are just going to thread each half of this union back on this and give it a test run. You know the drill. You just fire up the VFD, set it to the appropriate speed that we are looking for, and work our way over to the motor, and boom, we have beautiful and proper rotation. It's a little bit mesmerizing and truly a thing of beauty. Now all that's left is we just need to button things up, replace this back cover on the electric motor, replace the rotor shroud back onto covering the rotational assembly, power the VFD back onto automatic function, and voila! We have successfully replaced a 3-phase motor.